Okay, so welcome to this tutorial. Okay, we will continue um, with mechanics of matrix multiplication. And if you recall, let me split the screen into two first. So, to our tutorial here, example. We will do just one big one, okay? And before I start the tutorial, if you remember from the previous video, from the lecture, um, we have discussed, I'm just going to go through the main thing, okay? We have seen here, we have seen the unit matrix, so here, okay, if you see, yeah, okay, this concept is important because we said that if you multiply an ij matrix from the left, what does it do? It acts on the rows, okay? And the other concept is here we say that if we have more than one entry, okay? If we have two entries, so here I'm here, number 5 here, okay? If we have two entries, two non-zero entries in the elementary matrix, okay, and they are in the same row, then the actions do interact. This is also important because in the tutorial we are going to do Gauss elimination using these elementary matrices, okay. And the other concept we have seen in the lecture is regarding the identity matrix. We say that if you multiply a matrix by an identity matrix, it doesn't do anything to the matrix. Okay, so you can see it is leading us to the Gauss. We are going to do Gauss-Jordan elimination. So basically, we are going to use identity matrix to be able to recopy the rows exactly. Then we might add another entry because in Gauss-Jordan eliminations we mostly work with the matrix combinations. So if you want to add maybe row 1 to row 2, we need to have two entries in the same row. Okay, this is the concept we have seen here because we want to add a row to another, so we want the rows to interact. Okay, so we are going to use entries in the same row. Okay. However, we are going to also use identity matrix to be able to recopy, certain rows. And the other concept we have seen is that after using those, I'm here, okay, I'm here in the corollary. Okay, after using those elementary matrices, okay, if we can multiply them together, so basically the corollary is saying that for any matrix H, there are elementary reduction matrices. Those matrices, okay, unit matrices or identity matrices, or matrices where we have non-zero entries in the same row, okay. And so it says there are elementary reduction matrices R1 till RR such that if we multiply all those matrices together with, okay, H, we are going to get the reduced echelon form. And the order does matter, okay. We are multiplying from right to left. You see, R1 first, R2 first, till RR last. Is that okay? And those elementary reduction matrices are, okay, the same matrices we have seen here. Okay. So we can either multiply a row by a number k. So we have seen a rescaling matrix. Okay. We have also seen permutation matrix for number 2 here, and we have seen combination matrix. Yeah, matrices by having two non-zero entries in the same row. Okay, so Now let's start with the tutorial. Okay, the tutorial says, okay, it says perform Gauss Jordan method using elementary tree reduction matrices. Okay, so on the following matrix. Okay, matrix H, which is this is a 3 by 3. 1, 2, 0, 2 minus 1, 0, 3, 1, 2. Okay, so that is our matrix. So how are we going to perform that? So I'm going to change colors a lot, okay, to be able to show what we are doing. So basically, I'm going to work from the left, okay? So multiply from the left. Okay, so I have our main matrix 1, 2, 0 there, and 2 minus 1 is 0, 3, 1, 2. Okay, so I'm going to multiply it first with the following matrix. So first of all, I'm going to recopy to have an identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. That means I am recopying exactly all these 3 rows. Okay, now we are performing Gauss-Jordan method. Okay, so what we are looking for is to use the one here, this one there, okay, the one there, to be able to eliminate the 2 and the 3 below the 1. Okay, so that means I want so for example, to be able to use row 1 to eliminate the 2 in row 2, I want to combine these 2 rows. Okay, so what I'm going to do is I'm going to here I'm going to put minus 2 here because I want minus 2 row 1 plus row 2 will help me to eliminate the 2. Okay, and if you remember, what does unit matrix unit matrix an elementary matrix multiplying from the left does? So here we have minus 2 there, minus 2 position is row 2 column 1, so it is going to copy row 1 into row 2. You see, it's going to copy row 1 into row 2 and multiply it by minus 2, or multiply row 1 by minus 2 and then copy it into row 2. Okay, that's what we want for Gauss-Jordan elimination or Gauss elimination. First, we want to do twice row 1 minus 2 times row 1 plus row 2. Okay, so what do we have here? So we have 1 here. It is copying row 1 into row 1. It is not doing anything there. And here it is copying row 2. Here the minus 2 there is going to multiply twice row 1. It's going to multiply row 1 by minus 2. So minus 2 times row 1 is equal to minus 2 times there is 0. And then minus 2 minus 1 is minus 4 minus 1 is minus 5, and here 0 0. Okay, so but here the I here is just copying row 3. It's just recopying row 3. So we have 3 1 2. Okay, so what I'm going to do is I'm going to recopy that matrix here. Okay, 1 2 0 0 minus 5 0 3 1 2 equals, so my new elementary reduction matrix what I'm going to do is I want to multiply. So let me recopy my identity matrix. 0 0 0 0 0 1. Okay, but I want to multiply um, row 1 by -3 to be able to cancel that 3 there. So here I'm going to rub that 0 and put -3 there. -3 there, its position is 3 1. So it's going to copy, it's going to multiply row 1 by -3 and copy add it to row 3. Okay, that's actually exactly what we are looking for. So okay, row 1, we are copying row 1 into row 1. Row 2 as well, we are not doing anything to row 2. -5 is 0. And row 3, okay, for row 3, we are going to multiply row 1 by -3. So this is 0. -6 plus 1 is -5. And yeah, 0 there, 2 is 2 there. Okay, so the next step, I'm going to recopy this matrix here. So we have 1 2 0 0 0 -5 0 -5 2 equals. So we have here, okay, my identity matrix 0 1 0 0 0 1. So what I want to do next is to use -5 in row 2 to be able to cancel the -5 in row 3. Okay, so what I'm going to do is to multiply row 2 by -1. Okay, so I'm going to multiply row 2 by -1. So I'm going to change the 0 here with -1. So the position of that -1 there is a third row, second column. So it's going to multiply row 2 by -1 and add it to row 3. Okay, so here we are not doing anything to row 1, so we are just recopying row 1 because of that one there. That one there as well is not doing anything to row 2, so we recopy row 2. And the -1 and the 1 here means that row 1 and row 3 are row 1, row 2 and row 3 are interacting. So we have a 0 here, -5 -1 times -5 is 5, so that's 0 there, and we have a 2 here. Okay, so this is recopied there. So let me continue here. Okay, the result is 1 2 0 and 0 -5 0 0 0 2. That's my matrix or our matrix. And maybe that's too big because I want to save space. I want to have enough space in this one slide. So our result is 1 2 0 0 -5 0 and 0 0 2. Okay, let's write our identity matrix here first, and we will change it 0 0 1. So what are we going to do? What is the next step for in Gauss-Jordan elimination is to have to turn all the diagonal entries into 1. Okay, so I'm going to multiply row 2 by -1/5. We have seen a rescaling matrix, so here we are just going to change. We are here, okay, we are going to change that 1 there into -1/5. Okay, so -1/5. This will multiply rescale row 2, okay, so that we can have 1 there. So let me continue. The answer is 1 2 0 and multiplying row 2 by minus 1 over 5. This is 0, this is 1, this is 0, and we are not doing anything to row 3. Okay, so that's that one done. The next step in this is 2, not, we are not there yet. Okay, so the next step is to divide, to have 1 in this row 3. Okay, to turn the 2 into 1. So here I have 1, 2, 0, 0, 1, 0, 0, 0, 2. Okay, and I'm going to multiply it by a rescaling matrix. Okay, so I have my identity 1, 0, 0, 0, 1, 0, 0, 0, 1, and I want to turn that 2 into 1, so I'm going to multiply row 3 by a half. So I'm going to change that 1 into a half. Okay, why my zeros look funny? So multiply this by a half. Here we have 1, 2, 0, recopying row 1, recopying row 2 as well, and dividing row 3 by a half. Sorry, so this is 1. One there. Okay, so the next step is to use row 1, row 2. The next step is to use the 1 in row 2 here to be able to cancel the 2 in the row 1. That's 2 there. Okay, so let's recopy our last result, which is 1, 2, 0, 0, 1, 0, 0, 0, 1 there. Okay, and we are going to multiply it first by the identity matrix. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. And what we want to do is we want to copy row 2. We want to have a minus 2 times row 2 plus row 1. Okay, so what it will give us is here, I'm going to change that 0 there into minus 2, and look, minus 2, and the position is of that minus 2 is row 1 column 2, so it's going to first of all multiply row 2 by minus 2. It's going to rescale row 2 by minus 2, and then copy the result into row 1. Okay, so that's what we want. So here we have 1. Let me copy row 3. We are not doing anything to row 3. We are not doing anything to row 2 neither. So row 1, we are just multiplying. We are adding minus 2 times row 2 to row 1. So this is 0 and 0. So this is our final answer. Okay. And yeah, that's our final answer, our Gauss-Jordan done. Okay, and from the lecture, if you remember, so it says in our last corollary that for any matrix H, there are elementary reduction matrices R1 till RR, such that if we multiply all those R, but remember in reverse order. Okay, multiply by H, we can, if we multiply those elementary reduction matrices by H, we will get the reduced echelon form. Okay, so our R, so here is let me finally we have okay, this is, so we are going to go this way. Okay, so let me write the last matrix is 1 minus 2, 0, 0, 1, 0, 0, 0, 1. I hope I will have enough space here. And then the second one, so this is RR. Okay, this is the, so this is R1, R2, R3, R4, R5, and R6. So we are going to write it that in reverse order: R6, R5, R4, R3, R2, R1 multiplied by our H. Okay, so here my R5 is 1, 0, 0, 0, 1, 0, 0, 0 and a half. And okay, the next one is 1, 0, 0, 0 minus 1 over 5 is 0, 0, 0, 1. And R3 is 1, 0, 0, 0, 1, 0, 0 minus 1, 1. And R2 is 1, 0, 0, 0, 1, 0 minus 3, 0, 1. And our R1 is 1, 0, 0 minus 2, 1, 0, 0, 0, 1. And then multiply by our H. Our H here, which is 1, 2, 0, 2 minus 1, 0, 3, 1, 2. Okay, and it says that we should get a reduced and identity matrix. Okay, so we have a reduced echelon form because it's not every time we will be lucky to have an identity matrix. Sorry, yeah, an identity matrix. Okay, we are lucky here. This matrix is a non-singular matrix, so that's why we have an identity matrix. So 1, 0, 0, 0, 1. Okay, so I think I will stop here. So in this tutorial, we have seen how to get or how to perform Gauss-Jordan elimination using these mechanics of matrix multiplication. Okay, so see you in the next video. We will continue with the lecture, and we will start a new section about inverses. Okay, see you.